You know, when you walk past a massive construction site, cranes up in the sky, concrete trucks pouring, sparks flying from the welders, there's this ingrained assumption we all just kind of have.
Oh, yeah, like you just assumed the origin point of all that physical chaos was, I don't know, a roll of flat paper blueprints, right?
Right, a 2D drawing unrolled on some wooden table somewhere, or maybe just a simple CAD file on a desktop.
Sure.
But what if I told you that by the time that very first shovel actually hits the dirt, the massive skyscraper or healthcare facility they're building has already lived an entire lifetime?
That's crazy to think about.
It really is. It has breathed, it has operated, it's had its power grid fail, and it has literally survived simulated disasters.
Hmm.
And all of this happens before a single physical brick was ever laid.
Yeah, I mean, it is a complete paradigm shift in how we understand the built environment today.
Definitely.
We are no longer just, designing buildings as static objects. We are practically giving birth to them digitally first, running them through their paces, and then using the physical materials as well, merely as a printout of a perfected digital masterwork.
Which is exactly why we're here today. Welcome to today's deep dive, everyone. It is June 23, 2026.
International Women in Engineering Day.
Exactly. And to mark the occasion, we're exploring a truly insightful publication by Roots BIM LLC. It's titled Women in BIM Leading the Digital Engineering Revolution.
Such a great piece of research.
It really is. So our mission today for you listening is to unpack how the architecture, engineering, and construction industry, which we'll just call the AEC industry, is undergoing this massive fundamental digital transformation.
Right, the shift is just unprecedented.
We're going to explore how building information modeling, or BIM, has evolved just light years beyond simple 3D modeling, and importantly, how women engineers are at the absolute helm of this shift.
Yeah, they are literally building our modern world in a digital landscape long before it exists in reality.
So let's start with that distinction between 3D modeling and modern BIM, because I think that's the perfect place to start.
I agree. For a lot of people, when they hear the term digital modeling, they picture like a basic 3D shape on a computer screen.
Like a hollow wire frame of a house or something.
Exactly. Or, a video game asset.
Yeah.
But modern BIM is this comprehensive digital engineering ecosystem. I mean, it relies on deep data, simulations, automation, and predictive analysis.
Let's define what that ecosystem actually looks like in practice, because honestly, it shatters that old school perception completely.
Oh, totally.
The women engineering these projects are handling really complex multidisciplinary coordination. They're integrating architectural design, structural integrity, and MEP.
And we should probably clarify MEP for anyone outside the industry.
Oh, right. MEP stands for mechanical, electrical, and plumbing systems. So basically, the entire nervous system and respiratory system of a building.
That's a great way to put it.
Thanks. But they're taking this so far beyond 3D. They are implementing advanced dimensions of modeling, specifically what they call 4D and 5D BIM.
Yeah, and the jump from 3D to 4D and 5D is, well, that's where the whole concept of a static blueprint completely disappears.
You know, the best analogy I can think of for this is the difference between taking a photograph and building a video game.
Oh, I like that.
Right. Because old school 3D modeling is essentially like taking a digital photograph. It gives you a really great sense of what something looks like at a frozen point in time, maybe from a few different angles.
Look at this visual.
But modern 4D and 5D BIM, that is like creating a fully playable, cinematic, virtual reality simulation. In 4D, you add the dimension of time.
Right, which changes everything.
Because you're linking 3D objects to an actual construction schedule. So you can literally fast forward time to watch the logistics unfold step by step. Week 1, the foundation pours. Week 3, the steel skeleton rises.
And then 5D comes in and integrates cost.
Yes. Every digital beam and pipe is linked to live material databases. So while you're fast-forwarding time in your simulation, you're watching the budget dynamically tick up on the screen, almost like a taximeter, as these virtual materials are installed.
And as that simulation runs, the BIM engineers are conducting these extremely technical procedures like clash detection and constructability analysis.
Let's slow down and define those, because they sound like really intense engineering terms, but the underlying concepts are crucial for you to understand the real value here.
Absolutely. So think of clash detection as literal physics enforcement.
Physics enforcement, okay.
Yeah, because in a 2D blueprint, it's very easy for a structural engineer to draw a steel support beam on their paper, and then the HVC engineer draws an air duct on their paper.
And nobody realizes until they're on the job site that the air duct runs straight through the solid steel beam.
Exactly. That is a physical clash. But in a BIM ecosystem, the software mathematically analyzes the physical coordinates of every single object. It instantly flags if two things are, occupying the
Yeah.
same space.
That's incredible. And constructability analysis, what is that exactly?
That is proving the building can actually be put together in the real world without defying logistics.
Give me an example.
So the computer simulation might say the air duct fits perfectly in the ceiling.
Yeah.
Sure. But constructability analysis asks, how does the physical human worker actually get it up there?
Oh, I see.
Right. Is there room in the downtown alley to park the specific crane required to lift the duct? Is the hallway wide enough to carry this 20-foot pipe before the drywall goes up?
Hmm.
It's simulating the chronological sequence of human labor.
Wow, that really shifts the entire mindset of construction because historically it's a reactive discipline, right? You realize the plumbing pipe hits the steel beam and the work just grinds to a halt.
And then you hemorrhage money.
Exactly. You issue a change order, you wait 2 weeks for a redesign, but with 4D and 5D BIM, you're predicting those physical impossibilities in a digital void.
Which is free.
Right. A digital pipe hitting a digital beam costs absolutely $0 to fix. You just reroute it with your mouse before the raw materials are even purchased.
Which fundamentally shifts engineering from being reactive on the job site to being entirely proactive in the digital realm.
And to really understand why this proactive approach is non-negotiable, we have to look at the highest stakes application of this technology mentioned in the text.
We're talking about mission-critical data centers.
Data centers are the absolute backbone of the modern economy. I mean, if a commercial data center goes down, we aren't just talking about people losing access to streaming movies.
Not at all.
We're talking about financial markets halting, healthcare networks crashing, critical communications just going dark. The consequences are catastrophic.
Oh, completely catastrophic. And to prevent that, BIM integrates what Roots BIM LLC calls engineering intelligence.
Which means engineers evaluate thousands of potential design scenarios and failure states before a single trench is ever dug.
The sheer density of the data in these data center models is just staggering. When women BIM engineers are designing a facility that's going to house, tens of thousands of computer servers, they aren't just looking at structural walls.
Right.
They are incorporating electrical load distribution and these really intense thermal performance simulations.
Well, yeah, because a room filled with 10,000 servers is basically a giant oven.
Precisely. The thermodynamics are intense. So the engineering intelligence simulates the airflow dynamics and the fluid dynamics of the cooling systems.
So it knows exactly how hot things will get.
Yes. It calculates exactly how hot a specific server rack in the corner will get during a peak usage spike in the middle of a July heat wave. And it ensures the HVAC simulation can route enough cold air to that exact 3-foot radius to prevent a meltdown.
That is wild. And the models are also baking in these incredibly complex redundancy strategies, right? Just to make sure the power never drops.
Yeah, the redundancy strategies are the ultimate safety net. The industry standard terms you'll hear are N, N+1, and 2N redundancies.
Let's break those down.
Sure. N is simply the baseline amount of equipment needed for the facility to run at full capacity.
Okay, that makes sense.
Then N+1 means you have the baseline plus one completely independent backup of every critical component. So if a generator fails, the +1 generator kicks in seamlessly.
Okay. And 2N?
2N means you have double of everything. It is a completely mirrored, independent secondary system. A dedicated secondary power grid, secondary cooling loops, secondary data uplinks.
So if a literal lightning strike takes out grid A, grid B is already carrying the load.
Without a millisecond of interruption. By simulating the electrical loads of these different redundancy strategies, the technology transforms BIM from just a visual aid into a powerful decision-making platform.
Wow.
You can trigger a massive electrical failure in the simulation just to see if the 2N redundancy actually holds up.
Okay, wait, I actually have to push back here for a second.
Okay.
Because we're talking about running fluid dynamic simulations for thermal loads and triggering simulated lightning strikes on secondary power grids. But among all these massive macro-level engineering feats, the text specifically notes that these BIM models account for equipment maintenance clearances.
Yes, they do.
Are you telling me these highly trained engineers are spending their time measuring whether a guy can fit a wrench behind a server rack? I mean, that sounds like intense micromanagement, not advanced engineering.
Well, it sounds like micromanagement until a server fails at 3 a.m.
Okay, fair point.
Imagine a critical cooling valve malfunctions. A technician sprints into the server room to manually override it, right? but they discover a structural pillar was placed just 12 inches away from the valve housing.
Oh,
Exactly. The technician literally cannot fit their arm and the tool into the gap. Because of 2 inches of clearance, a manual override is impossible, the server rack overheats, and a $10 million outage occurs.
oh, wow. So the void is just as important as the solid space.
Exactly. They're literally designing the empty space around a machine. They're calculating the exact physical void required so that a future human being, maybe 5 years down the line, has the swing radius to turn a wrench or pull out a hot swappable hard drive.
That is fascinating.
Designing the invisible space for a future physical action is a hallmark of truly intelligent engineering.
But that creates an entirely new problem in my mind. If a BIM engineer is simulating thousands of thermodynamics, stress testing mirrored power grids, and measuring the swing radius of a wrench in aisle 4, the human brain simply cannot hold all those variables at once.
No, it can't.
The math alone would take lifetimes.
It would, and that is exactly why the actual technological toolkit women in BIM are utilizing right now is so advanced. They aren't doing manual calculus on paper. They are leveraging computational modeling and AI-assisted design validation.
The text mentions reality capture and laser scanning. Let's make that visible for the listeners for a second, because we aren't talking about someone walking around with a tape measure.
Definitely not.
Reality capture often involves flying drones through raw, empty elevator shafts. These drones are equipped with LiDAR light detection and ranging.
Right, which shoots millions of lasers per second.
Exactly. Bouncing light off the raw concrete to measure the exact distance, creating this dense point cloud. It's literally millions of digital dots that form a ghostly, millimeter-perfect 3D replica of the physical job site.
It's beautiful to look at, honestly.
And then you overlay that real-world point cloud onto your perfect digital BIM model to see if the concrete was poured exactly where the computer said it should be.
And that precise mapping feeds directly into another tool, automated rule-based model checking.
I picture this as the ultimate AI spell checker. But instead of checking a Word document for misplaced commas or typos, this system is scanning the digital building and checking for physics violations and building code compliance.
That's a great analogy.
Like, you load in the local city fire code, say, a rule that every emergency corridor must be a minimum of 48 inches wide. The AI scans multi-million square foot hospital in seconds, highlights a specific hallway in red, and says, hey, a contractor righted a high-voltage conduit behind the drywall here, which pushed the wall out by ½ inch.
Your corridor is now 47.5 inches wide. You are out of compliance.
Exactly. It just finds it instantly.
It's a highly accurate way to visualize it.
Yeah.
And if we look at the broader implications for the AC industry, this toolkit changes the role of the engineer entirely.
How so?
Well, by utilizing these automated checks and AI validations, women engineers are freeing up massive amounts of human cognitive power. When an engineer doesn't have to spend hundreds of hours doing tedious manual geometry checks to ensure a pipe doesn't hit a beam, that brain power doesn't just vanish.
Right.
It becomes a cognitive surplus.
So they basically stop acting as math calculators and start acting as innovators.
Exactly. They can redirect their energy toward optimizing the final physical structure. They can experiment with new sustainable materials, refine the thermal efficiency to lower the carbon footprint, and really push the boundaries of what the building can actually achieve.
But, all of this extreme data collection creates a massive new vulnerability.
What do you mean?
Well, having the most precise LiDAR point clouds and the smartest AI spell checkers in the world is completely useless if the data is fragmented.
Oh, yes. The silo problem.
Right. If the structural engineer is looking at an AI thermal scan from Tuesday, but the plumbing contractor is looking at a structural scan from Thursday, the entire project just collapses.
That is the classic silo problem in construction. Disconnected teams working from disconnected information. And this is exactly where the vital leadership and collaborative role of women in BIM becomes the glue holding the entire ecosystem together.
The Roots BIM text makes it really clear. The future belongs to those who combine technical expertise with digital innovation, and women in BIM sit perfectly at this intersection.
They absolutely do.
They are collaborating across a massive spectrum of roles. We're talking architects, structural engineers, MEP specialists, contractors, facility managers, and tech teams.
It's a huge coordination effort.
It is, and their ultimate goal: to create and fiercely protect what they call a single source of truth throughout the entire project lifecycle.
Yes.
And it's deeply ironic to me. In our daily lives, we constantly hear this narrative about how advanced technology isolates us. Algorithms replace human jobs, screens push us into our own little bubbles.
Right, that's the usual story.
But in the world of BIM, the technology actually demands intense, hyper-focused human collaboration. I mean, the BIM engineer isn't just a designer, they act more like the symphony conductor.
Or the central server of a massive multiplayer video game.
Oh, that's even better. Yeah, if one player in the game builds a wall, every single other player logged into the game needs to see that wall appear instantly,
Okay.
or the game's reality breaks.
Yeah.
The BIM engineer's leadership ensures that the architect, the electrician, and the plumber are all playing from the exact same sheet music or existing in the exact same digital reality. They ensure the game never breaks.
That central server analogy gets right to the heart of it. Because this single source of truth isn't just a corporate buzzword. It is the absolute holy grail of modern engineering.
Why is it the Holy Grail?
Because without it, the tangible benefits of digital design evaporate. Working from a unified model results in wildly improved project quality, plummeting construction risks, and much faster delivery. But perhaps most importantly, it guarantees greater operational efficiency and better life cycle asset performance.
Let's follow that thread for a second. Why does this digital unity matter for the life cycle of a building?
Because a building doesn't stop costing money the day the ribbon is cut.
Good point.
Think about the facility managers who have to run a commercial hospital for the next 50 years. True sustainability and operational efficiency are completely impossible if silos exist between the contractors who built the site and the people who run it.
Give me a real-world scenario.
Okay, imagine a specialized air filtration unit breaks down in the ICU 10 years from now. If the facility manager has to dig through filing cabinets for paper schematics, or guess what brand of filter the contractor ultimately installed because the final notes were lost in some email chain.
Yeah, efficiency plummets.
Exactly. But with a single source of truth.
Happens.
With a single source of truth, the facility manager just opens the digital twin of the hospital on a tablet. They click on the specific air unit. The model tells them the exact model number, the installation date, the warranty information, the maintenance history, and provides a 3D overlay of exactly how to access the unit without hitting the high-voltage wires next to it.
That is mind-blowing.
The BIM engineer's leadership in maintaining that unified digital vision during construction ensures that the building operates intelligently for decades.
So what does this actually mean for you, our listener, as you walk down the street tomorrow or go to work? Let's bring this all together. The central theme from the source material is undeniably clear. The future of engineering is digital. The future of BIM is incredibly intelligent, and women engineers are actively leading these massive transformations.
They really are. They're taking an industry that has traditionally been fragmented and reactive and forging it into a cohesive, proactive, data-driven ecosystem.
Absolutely.
They're ensuring that the infrastructure our society relies on is resilient, efficient, and future-proof.
So the next time you walk into a massive healthcare facility, or the next time you stream a movie or access banking data powered by a commercial data center, just think about the journey of that space.
They live a whole life before you got there.
Yes. That physical building you're standing in lived an entire digital lifetime before it existed in the real world. It was stressed, tested, and perfected in a digital void governed by immense engineering intelligence. The physical structures around us are essentially just the highly optimized physical printouts of a digital masterwork.
It really gives you a completely different appreciation for the built environment. Every beam and duct was argued over, simulated, and resolved before the raw materials were even pulled from the earth.
It really does. And I want to leave you with one final provocative thought to mull over. Building on this idea of smarter buildings and these highly detailed digital twins.
I love a good thought experiment.
Right. So we've established that women engineers are currently building perfect AI-validated digital twins of individual data centers and individual hospitals, meticulously mapped down to their thermal output and the exact physical void needed for a maintenance clearance.
Right, down to the millimeter.
But what happens when these intelligent buildings start talking to each other?
No wow.
If we have the computing power to digitally simulate and perfect one massive building, will the next step be entire cities operating on a single massive digital twin?
A citywide single source of truth.
Exactly. Imagine a citywide neural network where a hospital's digital twin is making real-time automated decisions about its energy use based on the live thermal data of the commercial data center 3 blocks away.
That is incredible to think about.
We started this deep dive talking about the death of the flat paper blueprint. It seems the blueprint of the future isn't a drawing at all. It's a living, breathing,